this weekend mainly just been making oil pipes. I wanted to remake everything because the original pipes were copper and pretty battered around. The bends on them weren't the best. It was flattened in some places. And I just wanted to redo it all and make it a bit better. I'm not sure I actually have made it better, but I think it's a bit more solid. The oil pump that came in the engine had actually been bought out for a bigger inlet pipe. They'd used a piece of copper pipe for that, bigger diameter, and this had all been drilled out to accept the bigger pipe. I'm not sure that's actually something you really need to do, especially on a non-race engine, when the size of the pump is fixed and the size of the rest of the piping is fixed. So I don't really understand what making the inlet pipe bigger would actually do. These engines don't have any problems with oil pickup or anything like that. It's not like you need to make it much bigger at all. And just making that one pipe bigger, I really don't know that that would do much. So I've gone back to the original style and the original layout. And this is the suction pipe. I've tried to give it the same little kick up here, and I've tried to do it more or less as original as possible, except for this oil filter. So I've soldered the pipe onto there to make that nice and rigid so it won't rattle around. I've discovered that all of the 1/8 pipes were soft soldered, and the 1/4 inch ones, which is these ones to the main bearings, these were actually silver soldered. And this is where I had a problem because I couldn't reuse the fittings. I did try unsoldering them, but you need so much heat to get the silver solder to come apart. You end up damaging the little solder nipples. So I ended up ordering some new ones of those. So these pipes aren't actually attached at the moment. They're just sort of sitting there, but that's where they'll go. So they'll go in there like that. Same with this one here. All of the 1/8 piping is in, so there's this pipe down here which goes out through the side of the block to the oil gauge pickup. Lucky I had 2 of these because it turned out the other one I was going to use had a stripped thread inside there, so that wouldn't do up nicely. The pressure release valve is here. I had ordered a new spring for that, but there are different length springs, and the spring I got was too short. So I've gone for the ball bearing in there on the seat. That seems to make more sense to me than the little cup thing. I can still change all this if I need to, of course. But this is done up. I'm reusing the old spring, which looked fine. So hopefully that'll be okay. This is the outlet pipe from the oil pump, and that goes out to the fitting. I use the proper bulkhead fittings in here. I've got Loctite on all of the threads and fiber washers anywhere I thought it could leak. So there's fiber washers in here and fiber washers in there. I had to double flare these end pipes. That worked fine with the little flaring kit I bought. This pipe originally ran parallel to this one, but this was one of the things I found funny on the original piping was this bend had to be a lot tighter then, and it had actually collapsed the tube a bit. So I made the bends as tight as I could with my little folder thing without the tubes collapsing, and it ended up being a bit higher there, but I don't think that'll matter because as long as the sump still fits, that's all fine. There's plenty of room in there for the oil piping. I may end up soldering a copper plate or a brass plate across these two just to join the two of them together, just to help make everything rigid. But to be honest, it's already pretty rigid, so I don't think there's any problem with vibrations there. But a little joiner thing won't hurt, which is what they did originally down here for the inlet and the outlet pipes. This is the original setup, so I will probably do that. Just little piece of brass or a little piece of steel. It's not going to rust, obviously, it's all in the sump. The oil pipe going to the oil filter, I redid that. So originally they had a big loop coming over here, and it just looked ridiculous. So this took a little bit of fiddling just to get the length exactly right and the angles all correct. But I only had to do it once, and now it's on there. It's all good. The other thing I did is I remade this block. This was kind of a fairly roughly made aluminium spacer that was in there originally, and I remade it from steel. The way this works is this is threaded because the holes in the side of the crankcase weren't threaded. So I've used 3/8 bolts through from the inside, so they thread through into this block and then protruded far enough to act as studs to actually bolt the oil filter on. This is all done up tight now. Again, there's gaskets in here to seal everything, and it was a little bit tricky getting the positioning of everything correct so that these fittings were all done up tight because they're on taper threads and in the right place, and be able to get spanners and things in there. It's not easy. The good thing is once this is done once, it never has to be done again. So everything's done up, everything's tight, and everything of course has to clear the crankshaft, which is a bit bigger, which it does. There's at least a 1/4 inch clearance around everything, which is good. I haven't actually tried this in the car, but there should be more than enough space here. If we actually look at the spare block, the external filter, everything's mounted down in this space here, so there's plenty of room, and it's all effectively hidden by the starter motor, which is good. I was originally, you might remember, going to use the little filter that somebody sent me, or I think I got them on trade now, I can't remember now. But in the end I decided not to use these because the oil filter in there is quite small. It is for a motorcycle with a fairly big engine, but then I found out that they actually use 2 filters, not just one. So I'm not sure it would be able to flow enough oil. And I've also heard these things are prone to leaking and also prone to cracking. So I decided to go with the original setup with the external filter. That just takes standard modern spin-on filters, because that's definitely going to work. And I do know that modifications like this don't affect it being a period replica. As long as it all looks correct, it's fine. This is a fairly standard modification to do on a vintage engine to give it an oil filter these days. So something like that doesn't make it not a replica anymore, if that makes sense. So the sump does fit, but I did have to, you can sort of see, I did have to put a little bit of clearance in the baffles for that pipe that goes out to the oil filter. I'm not sure I can do this with one hand. These studs are a little bit bent, but that does slide on top of there. The pickup's all in the right place, and all of these tubes do clear everything, so I think that should be fine. If we pull the pin out of this, it's quite interesting with everything in the engine and with the clutch and flywheel on, the stand's actually pretty well balanced. If I can get it upright. Tricky with one hand. I forgot my oil pipes are not attached, so let's get those out of the way. You can see from the manifold, one of the feeds comes up here, which oils the intermediate gear, which is this, and the feed from the end of the oil pump that we can see, which is kind of up in there, that feed there goes to the rocker gear. And one thing I hadn't done is screwed the little fitting into this after I'd soldered the pipes on, and that was really fiddly trying to get that threaded in while this was all attached to the engine. But I got there eventually. It wasn't too bad. It took a lot of rotating the crank and a lot of very small spanner movements. There's not a lot of space in there to spin a spanner around, so it was sort of like a sixth of a turn, or at times even sort of a 12th of a turn, where you had to turn the spanner over to get just a little bit more movement out of it. This is the feed for the rockers. It comes up to a joiner here. I haven't made the Y pipe yet. This is the one that came with the engine that isn't going to work, but you can see how that screws on there, and then that goes to the rockers. I need to make this piece, so I'll have to find a little piece of brass that I can make that from, but I've got all the proper banjos and things. And this tube is quite long, so I was a bit worried about that being inside there rattling around, so I actually made this little tab, I guess, this little P-clip type thing, just to hold all of that solid, because otherwise that's a big long length of copper pipe rattling around inside there. So it's not original, but I think that'll help. Can't hurt anyway. The engine is quite hard to turn over by hand as it is. I mean, you can do it. The main problem is there's nothing to get a spanner on to rotate it around. You kind of have to do it by turning the flywheel, and I'm always very wary of not getting my fingers caught in there. But there is quite a lot of friction from the rings, of course. So when you rotate the engine, you can actually feel the amount of friction on it changing depending on where the pistons are. So when you get it so two are at the top of the stroke and two are at the bottom, there's a lot less resistance than when they're halfway down, because when they're halfway down, of course, they're moving faster, so there's more friction there, and you can feel that as you turn it over by hand. I don't think it's too tight because it is a brand new engine, of course, but once I get the rest of the oil system actually finished, I'm quite tempted to turn this the right way up, put a container of oil underneath the pickup tube and actually bolt the starter motor on and spin it over on the starter and just make sure that oil is coming out of all the places there should be oil coming out of. I think that might be a fairly sensible thing to do. And then also I'll be able to see if the starter has any trouble turning the engine over. But I don't think it will. I think it'll be fine. It's just, like I say, trying to do it by hand without a sort of bar on it, just from the flywheel while it's on the engine stand, which has wheels, so it all moves around, makes it a little bit tricky. So that should all be good, I hope. I'll probably try and get black oil filters for this, just to, again, kind of hide it away. But like I say, it's hidden down there, out of the way. And I think that's pretty much it. That's all I've really done. And like I say, that's taken me 2 days just to get all that done. It's really fiddly trying to bend the pipe, and it took me a few goes to get things right. And even then, you can tell it's not. I could have done it a bit neater. It would just mean now taking it all apart again, just to try and make some of this neater when it doesn't really matter, I think. So I'm going to leave well enough alone. Somebody, I think it was when I was talking about different channels I watched, and somebody said to me, oh, you should also check out, I think his name's Alan Milliard. He builds custom Kawasaki motorcycles, and fascinating channel. Whoever it is who sent me that, I've been trying to find the comments so I can thank you. But whoever sent that, I've been watching a lot of those, and it's very interesting. He leaves out a ton of detail, of course. He makes it look really easy. You just cut a couple of crank cases in half and then weld them back together to make a V12 sort of thing. And it's just, when you know enough to know what actually goes into that sort of stuff, you appreciate it a lot more, because it's not easy stuff to do. He's also really good with a hacksaw, I noticed. But I plod along. I get there eventually. I try to do it well enough so that I only have to do it once. And then once the sump's on this, that's it. It's all buttoned up, and hopefully I never have to touch it again. But the little nipple things should arrive during the week. I am going to try and silver solder those because that's what seems to have been used originally. On the ones that were on here with the copper pipes, they'd actually been soft soldered. I'm not sure that would actually cause any issues, but given the originals were silver soldered, that's what I'm going to try and do. And then I think next on the engine will be putting the camshafts in. I have checked and made sure the camshafts do all fit in there and don't hit any of the oil pipes. And because this is a Bitzer engine, the timing marks on the flywheel are all completely wrong on the flywheel and clutch, so I'm going to have to redo all of those. And I'm going to actually have to try and figure out the cam timing, because normally there are marks on these and you just set it up to the marks. I think actually if we look at yes, you might be able to see at the top there's a little E on this, which is the exhaust cam. Before I can do that, I have to put in all the cam followers, and that's not easy when an engine is the normal way up, apparently. But because I can tip this over, you can drop the cam followers into the holes from inside. They'll fall down, then you can put the cams in, and then when you tip the engine back up, the cam followers will drop down onto the cam. But first I need to figure out the actual timing of this, and that's going to be interesting. I understand the theory, I don't actually understand the practice of what I need to do. The other thing I want to do is get this whole thing a really good clean. Everything's covered in oil. I just put oil everywhere, and I try to keep it all covered up and nice and clean, but just with working on it, it picks up dust and bits and pieces. So before it goes together for the final sort of assembly, I want to give it a good clean. But that's looking better. It's getting there. I was just doing a quick test assembly, effectively, with the camshafts in and with the head I'm going to use actually on the block. And I've noticed what might be a problem, or at least something I think I'm going to need to modify and enable to get all of this to work. And I think I've mentioned this before, and this is the first time I've actually seen the practical implications of this, but the way the oil feed works to the rocker gear on these engines changed at one point. So it all became internal feed, and the blocks are different, the heads are different, the rocker covers are different. And the problem I've got is I've got a mismatched set of parts, because I have to use what I've got to make this work. And this block is an external oil feed block, so there's no oil feeds in this itself. These holes here are how you get oil to the cam bearings. So oil is meant to drop down through these, and that goes directly into the front and back camshaft bearings. You probably can't actually see them down inside there, but you can see how they line up with the cams. So you need oil going down inside there. How that normally works on a external oil feed engine, I believe, is the head looks like this, and these are the holes that match up to those oil feeds, and effectively oil just goes up into the rocker gear through the shaft here, and then drips back down, and it goes back down through these holes, which is what gives enough oil to oil the cam. And this is the head I was originally going to use, but it turns out I couldn't use this one because it's too rusted, and the water jacket had started breaking through into the holes. I did sleeve a couple of them and then realized that it was just going to be too dodgy to use this one. But this is the correct external oil feed type of head. So this is just kind of a bridge. So it's open all underneath there. So oil drips down into those holes. The head I am using, which is in much better condition, is the other kind, where this is meant to have the external oil feed. And I believe the oil would come up through there. And this is where the rocker covers become important as well. So if we look, this one. So this one you can see has an extra little boss with a hole in it. And that matches that hole in the head. So oil would come up there, and that's how it gets to the rocker shaft on this one. But I'm using the other style where the oil feed is external, and you can see there's no extra boss and no little holes. Ouch. So when this fits on here, this is why I need the external Y pipe for the oil. But now what I'm worried about is, because it doesn't have this feed, no oil is going to get down into the front cam bearings. The rear one is okay, that works the same. You can see it just sort of drains back through. So what I'm wondering is, do I need to drill a little hole? Because I don't think there is one. Well, if we can... That's one of the head studs. You can't actually see the light because there's a bend down inside there. But I'm wondering if I should drill a hole down through here to break through into that little oil passage so that the oil can drain down through there and drop down onto the cam bush. So that's something I'm going to have to find out about. I might post that question on the forum and see what people think. But I know it is doable. People have been doing this for years, so there will be a way to do it. I'm just not entirely certain what it is at the moment. The reason these covers fall off is these clips actually go over the rocker shaft, and that's what holds those in place. These are very prone to leaking, apparently. You need quite a thin gasket in there, and what you see a lot of people have on their cars is an aftermarket thing where you have a longer stud in the middle and a sort of clamp that holds these down, puts a bit of pressure on them. But yeah, this is going to be interesting. The rears do just go straight through, so it's only the front that's going to need modifying. And I think, yeah, that is open underneath there. So this does connect through into here, I think. I'm pretty sure. Yeah, there's my wire. So I think if I just somehow get it so the oil can drain through into that that hole, that should work. It's another fairly hot evening. I'm out in the shed again, still playing with the engine. You might notice there's a piston missing. I was lying awake last night thinking about how the engine seemed a little bit hard to turn. It's very difficult to tell because there's nothing you can easily get a socket on to actually try turning it. The only way I can really do it at the moment is by turning the flywheel. But it didn't seem right to me, and it seems like it got tighter after I'd fitted the fourth piston when I got the new piston rings. And it occurred to me that I hadn't actually checked the piston ring gap. So first thing this morning, I came out here before work just to quickly take that piston out and check the rings. I managed to break one again. Actually, I managed to break two, which is very annoying, but I did check the gap on one of them, and yes, it was very tight. So I did have to file the gap. And I should have known that because I had to do that on the other ones as well. So it always pays to check. Of course, the problem is now I don't have any more spare piston rings. So once again, I have to order those from the UK. I'll get a couple of extras because I seem to break them pretty easily. And this is after warming them up in your hand and that sort of thing. It seems to be getting them off that is more of a problem than getting them on. It's just a bit difficult. I do have a proper piston ring compressor tool thing, but it doesn't fit these pistons. They're too small, so it won't actually work. So I'll have to do an order and get those. I have fitted the studs for the front timing cover. I probably need to order the gasket for this as well. I'm not sure I've got that one. I've got some gaskets. I need to dig those out and see what I've got and what I'm missing. But one of the things I'm going to need to work out is the intermediate gear here on these earlier engines. There's just this cap, and you can see there's a gap there. So obviously I need some sort of thrust washer in there, or some sort of bronze washer, something to stop that gear from rattling around. You can see if I lift it up, there's quite a bit of movement there. The other thing to note is it's lifting up off the eccentric sleeve, and I believe that is supposed to be quite a tight fit on there. It's all keyed so it won't move, so when there's a thrust washer in there, it isn't going to cause a problem because they can't lift like that. If there's a washer in there, they'll stay together. But I think when I do the final assembly, I might use a little bit of Loctite bearing fit in there to make those nice and tight on each other. So I think I should just be able to machine up some sort of bronze bearing to go in there just to take up that gap. This is why it's important I know what the thickness of the gasket is. So I probably need the gasket first, then I can measure it up, and then I can make that little washer. And that's what tidies all of that up. There'll also be a gasket in here, I guess, so this doesn't leak. So you have to take that into account. I can't remember what the end float needs to be. I think it's 2 thou on this intermediate gear. It's not very much at all. So those are things I need to order. I have the solder nipples for the oil piping on order. They're local, so hopefully they won't take too long. And I'm also looking at the Magneto. So I have sent off the Magneto to a chap in New Zealand who rebuilds them. And I actually had a really good chat to him because he was explaining to me the process and what he does. And he was talking about how he remanufactures some of the parts now because you just can't get them. Or it's very unreliable for him to try and order them from the UK sometimes, and then parts turn up and they're not right, or they're not very good. So he's been looking at making what he can, and he basically does CAD drawings of things and then has things 3D printed. So we were chatting about 3D printing a little bit because obviously that's something I play with as well. But in the meantime, I'm looking at the rest of the Magneto stuff. I did order a new shaft and gear. Somebody did offer me their spare ones of these, but since I can get them, I can buy them. There's no trouble getting them, so I don't mind paying for them. I did forget to order, there's what's called a long nut, apparently, that goes up inside there, which is what tightens this onto the actual shaft, I'm imagining. And I'm just looking at this bush that's in here. So the way this works is that gets pushed on there. There's a little woodruff key. It won't go all the way on at the moment because there's a little machined step in there to make it a really tight fit. But if you imagine that gear goes inside there, and so this end of the shaft must run in a sort of bush there. But that's very loose. I've got 2 of these. That one's even worse. It looks like the bush is missing from this one, but you can see the bush in that one. if it focuses. And there's also a little sort of ring on the bottom there that's stuck in there behind that bush. I don't know what that is. I'm wondering if it's a broken off end of a shaft like this. Oops, that way around. So this definitely shouldn't be that loose. I think I need to replace that bush, but it's a blind bush, so pulling it out could be interesting, and it looks like it might even be pinned. Is that a pin in there? I'm not exactly sure how this works. So that's something I need to look into as well. If I can extract that, then I can make up another bush for inside there. That's no problem. Might be better to use this one. It just needs a cleanup. This one was all vapor blasted, which is why it's so clean. But that's okay. It might be easier to use this one than try to extract the bush out of there. And I did actually manage to buy a spare Magneto. It's really just a parts Magneto, which is this one, which is a Lucas one. But these things come up so rarely. When I saw it, I thought I'll just grab it, because if the BTH one is no good, maybe this one will be better. I think most of the parts of it are there. So obviously it wouldn't be gear driven. I'm guessing in theory this should. It won't go on because of the gear, but you can see the 3 holes will match up. So this mag is the right kind for a Riley 9, so I do have that kind of as a backup. So the Magneto rebuild is going to take a while. I think he said he's so busy it'll be 6 weeks before he can even look at it. So it'd be good to get the engine all finished, but obviously I can't rush too much. Getting the new piston ring and a few other bits and pieces from the UK will take a few weeks anyway. I did have to repair one of the threads here for these studs. I had to helicoil that, and I need to get the studs that hold the casing on. Don't think I've got those already, or make some. If Imperial high tensile steel bar was easier to get, I would just make all these things, but it's actually quite tricky to get hold of, but that'll bolt on there eventually. What else? I think that's kind of it. I'm very annoyed at myself for breaking those piston rings, but it's very, very easy to do, of course, because they're cast iron, so they're very brittle. And I thought I had enough spares, which I did, if you don't consider the fact that I had to take it apart and put it back together again. So that's okay. I'll order some more. I have tried to find them locally, and it's just too difficult. A lot of the people who were doing them now don't. Apparently it's not worth their effort anymore. And another place that used to do them, basically they said they had an old chap who used to come in and work the machine, and he stopped doing it, and there's no one to replace him, so they're just not making them anymore, and it's not worth training someone up apparently just to specifically do that, which is a shame. So these things are getting harder and harder to do in New Zealand, because people are disappearing and there aren't as many people doing it. So it's good we can still order parts from overseas. And I think that's it for today. I'm still puzzling over these Magneto housings and whether or not this is a bush in the end here, or exactly how this is arranged. I've been asking various people and posted on the forum. I'm just waiting to see if anyone has any ideas. But I did find this, which is a sintered bush left over from my Austin 7, and it's the right size for the shaft. It sort of fits in there nicely and rotates. And it just also happens, it's stuck now, but it also happens to be a reasonably good fit inside there. And so what I'm wondering is if I can, this could be tricky to bore out, but it may be close enough that I can assemble this with some Loctite, the bearing fit stuff, and set it up with the Magneto, get the bush pushed into place and let it sort of self-center, and then let the Loctite set, and that should hold it in the right place and have it all concentric. Otherwise I need to figure out a way of mounting this so that you could actually bore that out while still keeping it all completely concentric. I'm not sure how that would work. So I may still try to extract these, but it's going to be tricky. You can see there is a little bit of a lip under there, so I may just be able to get something under there and extract these out upwards. This one still has this, whatever this ring is, stuck in the bottom of it, so I have to get underneath that so you can sort of see it. It moves, but it won't actually come out. It's jammed in there. Actually, maybe I could just sort of pull that out somehow. But I'm waiting to get a few more opinions on what's actually going on here before I figure out the best way to fix that. And I've also been looking at the heads. So I do need to make sure oil gets down inside here, because I'm using the later setup where the oil is dropping down from the rockers into this valley, and that's what lubricates the cam bushes. You can see it much better on the earlier head where it doesn't have that boss where the oil comes up, and you can also see in here how this is actually machined out, so oil that collects in the valley here drops down through that hole. It's a bit dark, but there's the same on that side. There's actually a cutout there into that hole. So I think what I need to do on mine, this is my spare head, but it's the same as the one I'm going to use. It's so filthy you can't really see, so maybe I was poking around on this trying to figure out how all these passages work and what goes where, and which are the oil holes and which ones are the holes for the studs and which ones are for water. And I poked around in there and that came out of it. That's an earwig. I don't know how that got in there, but hopefully there aren't any more. Go away. So we glide this one down. The light's not very good. So down in there you can see there's a little lip around that hole, so I think what I need to do is grind that out a little bit so it's level with the bottom of the valley, and I'm going to have to somehow make a hole on this one to break into that passage level with the bottom of the valley, and it's going to be a little bit tricky, so I'm trying to figure out the best way to do that and the best angle to approach it from. We might be able to see it better on here, but you can see the light goes through, so this bridge doesn't go all the way down, so there is a hole under here. So effectively what I need to do is drill that way into that, this one's really oily, into the hole here. But this hole isn't there, it's actually a little bit further over, because it's in the same position as this hole, so it's quite close to the edge. So I actually need to drill through from there. So I think what I can do is just drill through from here and then slowly grind that out so that the where it breaks through is level with the bottom of the valley. I could maybe take out a valve at the spring and the valve guide and try to approach it from that way. But I haven't got anything that would really let me do that. I might just be able to sort of get a drill bit on an angle in along there to get actually in there and break through into that oil passage, sort of in along like that. It may be possible. So if I was doing it through like that, that might be better because the drill will be guided. This one is really filthy. I mean, I don't even know what that is. It's like tar in there. So this one would need a good cleanup, but this one is kind of my spare backup head I can use because it doesn't seem too rusted. If you look inside there, you can sort of see into the water passages and things, and it's not close to breaking through yet, at least from what I can see. So I think that's basically what I need to do, is somehow make sure oil can get from here where it collects down into that hole. Same on this side. This side's going to be easy. You just need to relieve that a little bit, which will be dead easy with a tungsten burr. And that's kind of where I got to today. So I'm not going to do anything in a hurry. I'm still thinking it through and getting different opinions, but pretty much that's what I need to do. I think you need to make sure oil gets down from the top to that front cam bearing. We can probably see on here. I don't know if we'll be able to see through down in there. That's actually the cam bush down in there, and you can see there's a hole all the way through, and that's the camshaft, and it should be the same on this side for the exhaust. Yeah, you can sort of see that. So oil needs to get down there basically.